Our next speaker today is one Amber Gillenwaters. You may be familiar with her. After 10 years of working in behavioral modification in a clinical setting, Amber has transitioned to a freelance career specializing in market research, data engineering, and data visualization. Quite a diverse stack. Her clients represent a variety of industries, including healthcare, education, workforce development, and entertainment. Amber is currently developing software providing automated processing of time series data for a leading medical device company with interactive analytic reports published daily and utilized nationwide. She is near completion of a dual master's degree. In fact, finals tomorrow,
Yeah,
Yep.
midterm. Today.
Today.
Yeah.
Man. Finishing that dual master's degree, crazy, in both computer science and experimental psychology, with a graduate certificate in data science as well as in statistics, and is active in the local tech community. I think we're in good hands with this presentation, so I'm going to step out of the way, and thank you, Amber.
All right, thank you, Mike. So today I want to talk to you about the strategy that you're using, that your firm's using to analyze data. He gave a very nice introduction, so I'll breeze through this one. So let's get right into it. So as you probably know already, the demand for data science is growing seemingly exponentially. It's worth now an approximated $187 billion, and it's rising. It's exceeding all projections for how fast it's growing. And this year alone, data science and analytics skills market is expected to grow by 30%. I think that number is probably even higher now. So if you aren't using these analytical skills in your work now, you will be, or you will be working with someone that does them. So my objective in the talk today is to make sure that you're clear on the terms you may hear and also the different tools that you may use. Try to demystify some of that and just try to provide for you a lot of the answers and a lot of the explanation that I usually give to clients. So I try to cover what I normally do with clients, what's popular now. With freelancing, I feel like you're very up to date on the pulse because you may switch projects a lot. I'd also like for you to consider the benefits of using a methodological approach in your own workflow. So by this, it will be different for everyone. It may be analyzing your own productivity, allocating your time during the day. It could be profiling and benchmarking. I find that it's fairly quick to do, but adds a lot of value to assess the different types of maybe an algorithm that I wrote or a function, to record that and provide the increase in whatever feature I was working on. So those are ways to think about that as far as your own work. So as we go, I'd like for you to consider that. It can also help you be more confident in decision making, make your results more usable, and make sure they're interpretable. Towards the end, I'll have a lot of pictures for you of pretty bad charts and visualizations, which you've probably seen before and maybe wondered, why don't I understand this? This isn't for me. But that may be because it's not a great chart to begin with. So I hope to help you be more critical of different findings that you see everywhere in the news, and things you may use at work, whenever you're assessing what products or tools to use. So this basic format will probably follow along with what you learned in the 7th grade biology class or something. But it's wise to use kind of the scientific method. And I want to focus here on planning. If you're a developer, you know that if you skip planning thoroughly, it can cost you a lot at the end, especially after release. So it's the same way anytime you're doing any kind of analytics, it's important to plan that really well to begin with. A lot of the clients that I work with made pretty big mistakes to begin with, and it can cost 10 times more the money and the time, even more than that. So first you want to identify what problem are you trying to solve and what do you expect to find. A lot of times I'll have clients ask me for something specific, and this is always what I ask right off the bat because oftentimes it may not be like the right approach. So this is really important that you identify what factor that you want to know. So this may be something like satisfaction with a product. How do you measure that? So you want to look at what are the factors at hand. So if we're talking about the benchmarking or profiling code example, it may be performance and accuracy. And also, how can you actually measure those? So when we look at something like product satisfaction, that's a pretty broad construct. So it's wise to break that down into different parts. So that may be something like satisfaction with speed, with the appearance, with the performance, with how practical it is to use. You also want to consider what form the data that you have are in, what methods you may use, and the fourth step I have here is your analysis, which is actually pretty quick. If you've done all the other parts appropriately, the analysis part is maybe 10% of the amount of time. And then reporting, so sharing that and providing visualizations of it. So I want to go through each of those steps and add some pointers, things to consider. So I talked about that briefly in the overview. You want to consider what are you trying to solve, or what do you want to describe, what do you want to estimate, what do you want to predict. There's two types of formal inquiry. You may have heard these terms before. You may be considering qualitative or quantitative. So a reminder, if you've heard this before, quantitative is typically like numerical data, and I'll talk about those a little bit more. Qualitative will be your quality of experience. So it may be more subjective in nature. Quantitative is hard numbers. So for quality of experience, I'm going to spend some time on this one because it seems to be really popular right now. If you're not checking in with your customers or clients or your employees before, during, and after whatever you're working on, whatever service you're providing, I might encourage you to consider doing that more because it can be really helpful, give you a lot of insight, make you be better. So some examples of that may be assessing how familiar are customers with your brand, how do people perceive your brand, how are people actually using your product, their overall user experience. It may be satisfaction is a popular one. And then moving on to quantitative, this is my favorite personally. Because numerical data can be categorized, it can be classified, ranked, and you can evaluate it. And with statistics, with machine learning, you can take a small sample and it has metric properties such that it can be considered to be representative of the population as a whole. So it's very conducive to like aggregation, estimating, prediction. Quantitative goes into qualitative, it should. You'll often see maybe like a Likert scale whenever you're receiving feedback. So Likert scale would be like a range from 1 to 7. How much do you agree with a statement? In that sense, we're getting some numbers so that we can assess that and use the psychometric properties to assess it. Whenever you have like fully open-ended questions, it can be difficult to parse, hard to aggregate. We need to use a more complex method to analyze those. So continuing on your planning phases, I want to talk about clarifying your target. So this part of this is operationally defining your relevant factors. So this may be in the form of like a questionnaire, feedback form, or survey. I'd like to know if you are, when assessing quality of experience, it's really wise to find a scale that's already done. So in some cases, it may be something that's never been measured before, especially if you have a really unique product or service. If you must make one, try to find a scale. It's not cheating, it's better. You can write a whole book about validating a scale. So it's really wise to base it off something like that. And I want to talk about some common issues when assessing qualitative work. So, and these I see pretty often. You'll see leading questions, double-barreled questions, too many. It should be pretty short, streamlined, just like in development. Or whenever you have true, false, yes or no, or too few options, it will be really hard to analyze at the end. So if you have just a yes or no, if they say yes, you don't know how much yes that is. To what degree do they agree? To what degree are they satisfied? A double-barreled question will be one where you didn't properly isolate the different parts of the question. So it includes more than one thing. And a leading question, I have a few examples of these. They're just very common. So something like, why was this difficult? Or to what degree did you struggle with change at work? It assumes that people did struggle with change at work and maybe weren't very happy with it. So a better one would be this middle question: what was easy or difficult about getting to the content you wanted? How did you feel about change at work? Okay, so best practice would be to write questions neutrally, to isolate those different parts of the question, limit those to only that are the most valuable, and to use an appropriate scale. This one's really important, and I see it a lot. Don't categorize potentially relevant numerical factors. Big ones would be age group and income range, unless there's a really strong reason to do that. And there's a lot of different places where people try to do this, but if you can, sorry, do you have a question back there?
Yeah, I've got a quick question.
Yeah.
When you're creating these questions, how do you keep yourself neutral? Like, are there keywords that you kind of look for or something like that to keep your questions from biasing your answers?
I think that, so he asked, how do you keep from how do you stay neutral? How do you keep from biasing your questions? I think a really close review, basing them from validated scale if you can find one. But I think a lot of the ones that I do are pretty unique. There's not another scale like it. So I'd say avoid any positive or negative terms. And a common one is, how much do you agree with this statement? If you do that, you can actually include positive and negative terms, but you'd want to include both. But I think just really close review and having a lot of people look at it, including people that are within the group that you're trying to test. That was a good question. So yeah, with age group and income range, it's really hard because I'll see companies do something like from 25 to 35 and from 19 to 24, and everybody falls in those groups. So then there's not much that can be done with it. I can't tell you what differences there are based on age. As people get older, they're slower. I'm just kidding. Are they slower? Are they faster? Are they more likely to purchase this product? Are they less likely? Are they more likely to drop out? I can't tell you anything about it because there's no differentiation. Open-ended questions do have their place, especially if you don't know what to ask. It's really wise to start with these or include some. And I think that a lot of times if you do have errors where it was unintentionally biased or something like that, or it was unintentionally confusing, an open-ended question can help you kind of salvage it because you can parse those answers and look at the factors that you were originally interested in. And find areas that you just wouldn't expect to explore more. It's really wise to check in with your employees, the people that are actually using the tool. I think that's missed a lot, even in software development. Kind of missing the mark, even though it's successful in doing a certain task, a function or something like that. Is it functional? Is it usable? So we're moving on to quantitative data. There's a few different types, and I'm sure you can think of examples from your own work of these different forms of data. So you have structured, which are clearly defined, they're labeled. Ideally, you want to store data in this way. Unstructured would be everything else. There's a lot of this right now with new advances in computational ability. Everybody has a lot of data assets that they don't know what to do with it. There's a lot of companies that will say, what do I do with this? And then you have semi-structured, which is some definition. And again, like in the benchmark profiling example, if you want to assess accuracy, what are different measures of that? It may be multiple measures. It's actually usually better if you have more than one form of it. So a common one, at least for me, may be percentage correct and speed. So it's something quantifiable. Okay, so next we will consider the potential approach. So there's a lot of different types of tests, a lot of different approaches out there, especially with machine learning being more accessible now than ever before. But it's important that you select the right one for your data. So in considering which test is appropriate, machine learning isn't always the answer. I think a lot of times it is simple descriptive statistics, especially coming from a stance where a lot of data engineering is needed when you have unstructured data. And then with inferential statistics, which means making predictions or estimations, If you don't have the right format and without proper planning, you can't do that. So that's disappointing to a lot of firms, is that if it's not planned correctly, it's not possible to make a prediction, to generalize based on the information that you have. All right, so I'll describe briefly, and I'm just going to touch on these. And I do this because a lot of my peers in school, they can do these really advanced machine learning approaches, but then when it comes to comparing them, it's difficult. So it's important to just kind of have a refresher, I think, especially now as these skills are so in demand. So different types are descriptive statistics. So that'll be like your percentages, your ratios. It could be a statistic like, was it significant? How much was the effect size? You may see some of those. You should look for those. It could be demographic information, maybe descriptive often. And inferential will be our more advanced forms, so making predictions and estimations about the population as a whole. So I want to cover this briefly. Again, as a quick refresher. So this is your normal distribution curve. So convenient quality or feature property of data is that it often falls in this nice little curve. You've probably seen this before. And if it's been a while, the top ends and the low ends are less likely to occur. So if you think about this as grades, which I think is easy to glom onto, because you probably dealt with that a lot of your young life. This will be your average. Most people are going to fall along here. At your upper end, you have the top 5th percentile. Those are people that did really, really well. And at the bottom, you have your lower percentile, and those are people that did really poorly. So, but most people are going to get in the middle, fall along the middle. So when it meets this, there may be parametric procedures that you can use. If it doesn't, if you have really big data that doesn't have a pattern like this, which is common now with huge data assets, you may use something like machine learning. So there's a few different types. You have correlation. So as this factor goes up, the other one goes down. As time goes by, profits are increasing. That'll be a correlation. A t-test is the comparison of two groups. And then you have an analysis of variance, which includes multiple factors. One thing I didn't include here would be like crosstabs or chi-square you may have seen. It's used a lot in business intelligence. An important thing to remember when you are comparing groups is to consider your sample size, how many agents, how many people are in that group. When they get really small, it hurts the confidence of your prediction or estimate a lot. So basically, if you don't have very many in each group, you can't make generalizations about that group. So if I have a survey or something of employees and it is accountants and bookkeepers, I have 273 accountants and 302 bookkeepers and like 15 other professions, I probably can't make generalizations about an electrician and be very confident in that. And I think a lot of research misses that. It's the things that you see in product testing and in the news. So within parametric, you have paired or unpaired. So These are called different things a lot of times, which makes it tough. But a paired could be pre-test, post-test. It could be a matched group. It could be people that are in some way alike. Sometimes they do that. Unpaired is between subjects or between groups, usually mean comparisons, the average. So if you understand that, that's pretty much the basis of statistics, all the different types, of which there are more. Parametric, at least, will be based on this. There's also some methods if your data does not follow this curve. The tests I mentioned, they are pretty robust to violations of assumptions, but it may be the case that a non-parametric test is more appropriate if it is highly skewed one way or another. If most people got Fs, you can do things like a log transformation, transform it to where it does look like this, so you can do some testing, or use a non-parametric procedure. Okay, so next we'll cover machine learning. You also see this called artificial intelligence sometimes. It's called a lot of different names. So I'd like for you to be able to recognize like when to use these. So the different types, you have regression, classification, clustering, neural networks, and reinforcement learning is the ones I'll cover. There's a lot of different types and really exciting changes that people are making within these different subgroups. Some of them are even combining each other. But I want to talk about them generally so that you can recognize maybe what will be the right approach for your project. So when we're talking about regression, it sort of looks like this. We're using the error and determining how far from a linear relationship each item is, and basically creating a function to fit your data to a line. So it can be pretty complex when we're talking about machine learning. Simple linear regression is a form of statistics as well, fitting it to a line. But with regression, it can end up very complex. But what's exciting about this is you can set it up to learn for you, to optimize itself. So there's a lot of different ways that you can change and handle this. But simply put, it's fitting it to a line. So the next type will be classification. This would include like your decision tree, random forest, should be a lot of decision trees. Basically, you are using the algorithm to determine which groups are present there. So it may be, is this person appropriate to loan money to? It could be, it could include a lot of factors, a lot of features that lead up to that, but it could be something surprising, which is really interesting about this. Something unpredictable will come out. In coding, you have regression testing. You'll find that following coding conventions will help you be less likely to make errors, more so than the type or the way you're writing or the language you're writing. So things like that make sense in hindsight, but it can be ways to discover those types of things and to prove what seems intuitive or to disprove it. So clustering would include like k-nearest neighbors, like distance algorithms. I really like these for textual data. So what words are occurring with this? What groups are likely to rate a project positively? So those are really useful for that. Next we have neural networks, which is also a really interesting application for textual data, because I think it simulates natural language processing. So basically, long story short, you have these different neurons. You have your input layers, you have your hidden layers, and you have an output layer. So each one is determining whether or not the next one will be activated using like an activation threshold. So if there's enough that is fed into this that is over a certain threshold, it'll move on to the next path. When you're talking about deep neural networks, they can be very big, like 100 layers with like 1 million nodes. What's interesting about neural networks is they can be impossible to know what's going on with them. So that would be like your black box. For a lot of problems, not more than 3 layers is sufficient. I think language processing is actually pretty simple. With only 2 to 3, you can kind of simulate that if you base it on sounds, which I think is what's used in like language recognition in the different devices, like your Alexa and Google Assistant and stuff like that. But yeah, these can be so big. And so what's interesting about these is you may be applying other types of the methods that I mentioned to classify what these nodes are like, or to cluster what these nodes are, to explain what it's doing. Because if you're like denying someone the ability to purchase a home, you kind of want to know what's going into that. Is it unfairly biased? So there's some that will output information about how they determine that. Or you kind of have some simultaneous things going on to prune it, to make it smaller. So reinforcement learning is another exciting area, especially applied along with the other ones. I see it a lot in like video game research actually, but I think it has a lot of applications, especially in human learning. So workplace training, education, schooling. It also kind of simulates what's going on in human learning. So you have your environment and agent. This is simply put. But what's neat about these is often they do look pretty simple. So whenever there's a positive outcome, it will basically receive more points. Sometimes a reward can be negative, like a punishment. So it may get less points or may kill it. And those are associated with the action that it's taking. So these can be used in optimization. And one way to make these really fast and improve on some of these really complex neural networks, I think, is to use more than one agent. So multi-agent would be, you basically have more than one of these running at a time, and they're competing against each other. So that's a way to optimize. It could be your code, it could be your data cleaning, which I really look forward to. So next I want to talk about your analysis a little bit. Speaking of data cleaning, according to IBM, data scientists spend about 80% of their time cleaning data. I find that to be true for myself, maybe even 90%, because the analyses tend to go pretty quickly, but I IBM predicts that by 2025, this may be a little ambitious because they have products for this, but that 50% of data science activity will be automated. And I hope it's mostly in data cleaning because it'd be nice to spend only 40% and more time modeling. But it's important to consider your data engineering and your structure. So typically, data is tabular in form, so in tables. Relational databases make data a lot more accessible, a lot more fast and efficient to process. But in smaller firms, the data assets have grown so quickly that the data handling is very inefficient. So I think that's where a lot of firms are now. In fact, I think it holds back a lot of companies that could have a lot of useful information on in their hands, but they can't handle it because of the way that it's stored. So again, planning is really important, and taking a step back and looking at how that is stored. There's a lot of different ways. So with big data sets like that, machine learning can be really useful in gleaning information. It can be really useful in data engineering, just getting that structured up to where you can use it. You can write something recursive that can organize it pretty quickly. So that's something to be aware of, is that sometimes you need some of these tools to organize it so you can analyze it. Okay, so reporting. It's important to consider how you're manipulating it. And I think this happens a lot in companies, that you have like a deadline. I know this happens in like software too. There's a way that you want to write it that would be ideal, but there's a time constraint. So you can tend to maybe cut corners. Well, unfortunately, the same can be true in analytics. This research was done about 10 years ago, but it was a really surprising finding. This researcher found that 40%, or a little under 40% of researchers admit engaging in questionable practices in analytics. So maybe dropping cases, stopping it early, or testing until something looks right. So I think in business intelligence, this could be more like stopping short, or having too many groups and just, okay, here's a graph, let's launch, without maybe taking that back a step and reconsidering. But it's unfortunate because you may have some chart that looks great, let's make business decisions on that, but it can lead to a lot of loss. Interesting, in that study, about 70% stated that they saw others engage in that. So I'd like to encourage you to consider carefully what different things you're taking into account. If you're evaluating a product that you want to use or tool, because, let's see, one would be, how much was included in it. I want to show you some pictures. So first of all, I want to kind of cover what's right in a chart. It should be readable at a glance. You want it to be clearly labeled, suitable range. Ideally, you'll see error bars and a sample size. Sometimes that's asking a little much. So this would be an example of what I thought was a pretty good looking one. I also like just a plain simple line graph when you're comparing something really complex. So here, these error bars represent the confidence interval. So a lot of times, if they don't show you that, it may be because this confidence interval is very wide. So they don't maybe have a lot of confidence in that measurement. But it's something that's ignored a lot. And something to consider. That is not a good one. It's a scribble. I don't know what that says. There's so many examples of these if you really look. Maybe you'll start seeing them all the time like I do. So here's some different types of bar charts. I usually advise against these. They're used a lot in business, but in this one, it's a little bit hard to read, I think. But you see each of these different groups, they're kind of the same. So I think I'd compare these with each other. Because these can be really hard to read, especially when you have so many different ones like this. But if you are looking at one of these clustered bar charts, one thing to look at is if there's a interaction where one of them flips. So if one of these is really high and then really low, you may want to look at what's going on with that. I'm hoping they're intending to mean this one means that it's pretty steady throughout the year. But you also see some of these, they represent a ratio. If you have a really low sample size, it may look like a group is quite different, but if it's only like 10 people, I don't think you can make generalizations about these, so it's careful to look at, you want to be careful about looking at the actual number in these. This is an example of not easy to read and misleading. You see the lowest one here is 75%, the highest is 82%. It looks like there's a lot more books in there, but really it's, if you actually chart that out, they're very close. And that's what I find in a lot of these analyses is when you actually compare them just back to back, there's not differences. There's another one like that. This one I just thought was neat. So this is a machine learning test, and they fed in these different types of charts. And this is how the machine, that procedure interpreted it. So I think this confirms that you should keep these simple looking like this because that's how people are reading them. So avoid a lot of different colors and stuff like that. I'm all about making it look good, but be careful with that. Should look more like this interpretation side. So it's important to consider and acknowledge any of those limitations and report them. All right, so finally, the last point I'd like to leave you with is that it's worth to critically examine the strategic data approach of your firm and in your own work. All right, thank you so much. Might have time for a question or two. Yes.
Do you recommend formal education to get into this industry, or can you be self-taught?
I think it's wise to start where you are and what you want to accomplish with it. For some, it's a better structure to have a formal training if you're interested in that, but you don't want to do like a full program at school. There's a lot of like mini degree programs. A lot of them are free. And mini certification. So if you're looking for one specific skill for your work now, those can be really useful. I think it depends on the application, but there's a lot of different ways to learn more about these. It kind of levels the playing field, I think, because it's so new that everybody's kind of new to it. So, but I think there's a lot of different paths to learning about these, just like software development. I know a lot of self-taught workers. Yes.
I feel like the data science field is like so big and huge to me that I really don't even know where to start, like in terms of even analyzing data or asking, like knowing which questions to ask about data. So like in programming parlance, you know, you have the Hello World apps for learning programming. Is there any sort of similar thing for data science, or trying to wrap your head around how to approach thinking about data and like your own products? Like if I wanted to see how I can make something better for my customers, my own apps, for example, like where I just don't even know where to begin at all.
Let's see. Give me a topic.
All right, are people enjoying the new feature I added?
Okay. So I think you're probably better at this than you think, and you engage in it a lot more than you think. So it's kind of just a matter of formally testing if people are enjoying it. So ways to measure that may be asking them. It may be the time they spent with it, the time they spent in certain areas, if you wanted to use quantitative data. It could be a comparison to a product that's similar to yours. So things that you wonder, you kind of want to stop and analyze those. But I think as a programmer, you probably do it more than you think. So I'd start there, I think. And Google it. I just Google questions all the time. Did somebody else ever look at this? Yeah. That's wise to do. Build on other people's success. All right. I think that's it for me. Thank you again.